Hello everyone, I am Madeline Weiner and welcome to Learn Nuclear Energy in 15 minutes. What is nuclear energy? Nuclear energy is known as atomic energy released during nuclear reactions such as radioactive decay, nuclear fission, and nuclear fusion. So, there are three important concepts in nuclear reactions, which are radioactive decay, nuclear fission, and nuclear fusion. Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiation. And how about nuclear fission and nuclear fusion? So, today's lesson will be focused on the learning outcomes 6.2.1 and 6.2.2 under subtopic 6.2 Nuclear Energy. At the end of this lesson, students should be able to communicate about nuclear reactions in terms of nuclear fission and nuclear fusion, and describe relationship between energy release during nuclear reaction and mass defect, which is E equal to mc squared. First, let's study the learning outcomes 6.2.1. Communicate about nuclear reactions in terms of nuclear fission and nuclear fusion. So, what is nuclear fission and nuclear fusion? First, nuclear fission. Nuclear fission is a nuclear reaction that occurs when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. And the common example of heavy nucleus in nuclear fission is uranium-235. Now, let's see what will happen in nuclear fission involving uranium-235 bombarded by a single neutron. So let's say we have a uranium and a neutron here. Then a uranium-235 nucleus is bombarded or shoot by a neutron. And we do not shoot it with proton because the nucleus carry positive charge and the proton also carry positive charge. If you shoot the nucleus of uranium with proton, then the proton will be repelled away or pushed away. It would not go into the nucleus. But if you shoot it with neutron, then this nucleus will absorb the neutron. This is uranium-236, which is the unstable nucleus. When a neutron absorbed by the nucleus, an unstable uranium-236 nucleus is produced. When the nucleus becomes very unstable, it will be broken into two smaller pieces. A krypton-92 nucleus and a barium 141 nucleus are produced. At the same time, 3 neutrons is produced and a large amount of energy released as well. These are the typical examples of nuclear fission. As I've explained before, uranium shot by a neutron and it broken into barium and krypton, and at the same time release 3 neutrons and energy. Another example is uranium shot with a neutron and it broken into xenon and strontium, and at the same time 2 neutrons and energy are released. Let's have a look at these diagrams. Nuclear power plant and a structure of a nuclear reactor. So, the process of nuclear fission is used in nuclear power plants. And the energy that is released in nuclear fission is used to generate electricity at a nuclear power station. As we already know, the energy that is released in nuclear fission is used to generate electricity. However, there are disadvantages of nuclear fission. It produces high-level radioactive waste that must be stored for 10,000s of years. So where does the radioactive waste come from? The radioactive waste comes from the uranium. Uranium is a radioactive element. When uranium undergoes fission, it generates radioactive waste along with energy. This radioactive waste is very harmful for the environment and the life forms. Next is the meltdown causes disaster like in Fukushima Daiichi Japan and Chernobyl Ukraine. Second is nuclear fusion. Nuclear fusion is a nuclear reaction in which small and light nuclei combine to form a heavier nucleus while releasing a large amount of energy. Examples of small and light nuclei are deuterium and tritium. And these nuclear reactions happens under extremely high temperature and pressure. Then why is nuclear fission not used to generate electricity? This is because for nuclear fission, two conditions are required. They are high temperature and high pressure. So, the energy is needed to overcome the force of repulsion between the positively charged nuclei. The nuclei must be heated to 100 million Kelvin or more, so that the nuclei will have enough of kinetic energy to overcome the electrical repulsion between nuclei. Next is the nuclear fusion between deuterium and tritium occurs to form a heavier helium nucleus. Here we have deuterium and a tritium, and they are isotopes of hydrogens. When we have two atoms or two nucleus, we make them combine together, so process of fusion will be occur. After the reaction, it produces a neutron, a helium, and a large amount of energy. So, this is nuclear fusion. We combine or jointed two nuclei together to form new heavier nucleus. Here are the examples of nuclear fusion. Deuterium combined with tritium will produce helium, neutron, and release energy. Or deuterium combined with deuterium will produce another helium, neutron, and energy. But this helium is 3 neutrons only. Then, where does the nuclear fusion takes place? Do you think the nuclear fission takes place in the laboratory? No, you are absolutely wrong. Nuclear fusion takes place in the sun. And this usually occurs at the center of the sun. That is how the energy is produced from the sun. Then, how do you think this energy reaches us? The energy released after nuclear fusion reaches us in the form of sunlight, ultraviolet radiation, and heat. Now, let us take a look at nuclear fission versus nuclear fusion. This is a table of nuclear fission versus nuclear fusion. The definition for nuclear fission is heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. And for nuclear fusion, small and light nuclei combine to form a heavier nucleus while releasing a large amount of energy. Nuclear fission is not common in nature, while nuclear fusion is common in stars such as Sun. Nuclear fission may require high-speed neutron, while nuclear fusion requires high temperature and high pressure conditions. Nuclear fission produces a high energy, and for nuclear fusion, reactions of light nuclei produce a very high energy, and reactions of heavy nuclei may not release energy. Last but not least, the examples for nuclear fission are neutron bombardment of uranium-235 and radioactive decay in unstable isotopes. And an example of nuclear fusion is fusion between deuterium and tritium. Now, let's move on to learning outcome 6.2.2. Describe relationship between energy release during nuclear reaction and mass defect, E equal to mc squared. In a nuclear reaction or radioactive decay, the total mass of decay products is always less than the total mass of the radioactive nucleus. There is a loss of mass occurs during the nuclear reactions. The loss of mass is known as mass defect M. Figure below indicates the examples of mass defect in nuclear fission. From this figure, we can see that the total mass before fission is more than the total mass after fission, and the mass defect M is equal to total mass before fission minus the total mass after fission. The relationship between the energy released during nuclear reaction and the mass defect can be summarized by following this equation. E equal to mc squared, where E equivalent to the total energy release, m is the mass defect, and c is the speed of light in vacuum. Here, 1 AMU is equivalent to 1.66 times 10 to the power of negative 27 kilogram. Let's see the example here. The sun is the source of energy to the earth. This energy is produced by the nuclear fusion in the core of the sun as shown in the following equation. Calculate the nuclear energy release in joules. And some of informations are given here. And the solution is shown as below. First, solve for the mass defect M, which is equal to 0.01 at AMU. Then, convert the unit AMU into kg. Then substitute the value of mass defect and the speed of light in vacuum into the formula. And the energy release in joules is 2.69 times 10 to the power of negative 12 joules. Let's test your understanding. Could you define nuclear fission? Nuclear fission is nuclear reaction that occurs when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Second question. Define nuclear fusion. And the answer is, nuclear fusion is nuclear reaction in which small and light nuclei combine to form a heavier nucleus while releasing a large amount of energy. Third question, in a nuclear reaction, the mass difference in the reaction is 1.5 times 10 to the power of negative 8 kg. Find the heat release in this reaction. The value of speed of light in vacuum is given. This is the calculation for the heat release. And you are going to use the formula E equal to mc squared. Thus, the answer for heat release in this reaction is equivalent to 1.35 times 10 to the power of 9 joules. So, that is all from me today. I hope you've enjoyed the video and I hope you've able to gain something from the video today. Please take care of yourself and thank you once again.